Pogo here, and welcome to the next episode of the Bukkit Coding Packets mini-series. In this episode, we're going to actually take a look at our first packet. This was one of the requests in the comment section of the previous video, and the idea was to display particle effects to a specific user. Now keep in mind that there are ways, I believe, to do this with regular Bukkit, but those effects will show up to all players. If you do it this way, you can actually show an effect to one player that the other ones won't see, which is an interesting concept. And there's also a lot of fine-tuning that you can do. You'll see there are a lot of parameters that you pass to the packet, and you can really control exactly how the packet is going to look to the user. So we are going to take a look at how to get this all set up. Now we actually don't need to use reflection in this, simply because there isn't a constructor for the packet that is exposed. So we don't really need to worry about that, which can get kind of ugly. And this code actually won't look too bad. So I have a base set up here. I have just a listener. I have a player interact event. And I'm just going to make it so that when I click on a block, it will create some sort of particle effect at that location, at that block. So of course, if the block is null, we want to return. But at this point, if they do click on a block, then we want to show an effect. So the name of this packet is the PacketPlayOutWorldParticles. The first part of the name is packet, which denotes that it is in fact a packet. Then we have play out, which means it's going out to the client. This is going from the server to the client, and the client is in charge of playing the effect. So this is something that's going out rather than coming in. And then world tells us that it's some sort of world event. Then there are other packet playout world packets. But then particles will tell us that this is in charge of packets. So the first thing we're going to do is we're going to instantiate this. We're going to create a new packet playout world particles. And you'll see if I look at packet playout, there are all of these different packets here. There are tons of packets. And a lot of these are just effects and different things like that. And we're going to look at some of them. So this is going to be the packet playout world particles. I'm going to name it packet, and I'm going to set it equal to a new instance, new. And you'll notice, let's take a look inside of here. This is the decompiled packet playout world particles class. We can see it has a default constructor that does nothing. And then it has a constructor here, and this is the one that we're going to concern ourselves with. Now you'll notice that this quickly becomes very confusing. We know the types of all of these variables. There's an enum particle, boolean, and then there are 7 floats. Is that 1, 2, 3, 4, 6, 7, and then an integer, and then an int array. But you'll notice that they're all named 2603, and then there's this where every variable is just one letter, and we all assign them to 2603. So this looks like weird code that wouldn't actually work, but I suppose it does. And then we can see down here, you can see the types of the variables A through K. So I can tell that variable A is an enum particle, or an enumerator particle, and then J is a boolean. So where it says J equals 2603, I know that that's referring to this boolean. But otherwise, there really isn't too much help. We can look at the other methods. There's this A method right here that takes a packet data serializer. And this method, just by reading it, I can tell that it is in charge of, it looks like it's in charge of reading the data. So given like a information about the packet, like, you know, all of these pieces of data in string form, it would convert it into a packet playout world particles. And then B is actually the opposite. It will write this information to a variable. It'll write it to a serializer so that it can be sent. Then we have this, which I guess just involves a listener, and it invokes some method on the listener. And then we have this, which takes a packet listener and just casts it to a packet listener play out and then calls this method. So there really isn't very much interesting in here, and it really doesn't tell us much. So when you're trying to figure out what these seven floats in a row do, you have to take some guesses and experiment, and possibly also look online and see if there's any help. So I went through and I did some experimentation, and I got a little help online, and I managed to figure out more or less what they do. There's a couple that I don't know what they do, honestly, but I know enough that you can spawn a pretty particular effect. So the first part is an enum particle, and that is very self-explanatory. Enum particle is an enumerator that contains all of these different particles. There's a ton of them. And you can kind of see all of these different effects, and each one corresponds to a particle that you would see. So flame particle, there's lava right there, there's portal, slime, all of the different little particles that you could possibly see. I like the little snowman right there. That's nice. So yes, those are all the different effects. Now, the one that I'm going to use to demonstrate this is the portal effect, and I'll explain why I'm using this one once we go through all of these values. So the first thing is going to be the particle that you want to display. So you just pick something out of enum particle, and you have a ton of options there. The next parameter is a Boolean. I just set it equal to true. I've experimented setting it to true and false. I'm not completely sure what it does, but we're just going to leave it true. It's probably just some sort of flag, and I'm not going to worry about it. Then come the important parts. The next three parameters are x, y, and z in the form of floats. So this is the x, y, and z coordinate of the effect where you want this to happen. So in this case, it's going to be e.getClickedBlock.getX, and then e.getClickedBlock.getY, and then e.getClickedBlock.getZ. So again, this is, I'm going to keep a running track. I'm going to say this is the particle type, and then this is just true. This is just x coordinates. This is the y coordinates. This is the z coordinates. Okay, the next three are the offset x, y, and z. And it confused me a little bit, but I believe that what it does is it sort of controls the radius or the area of this. So if you set these to be 0, I'll show you what that looks like. It's going to stack them all up in a tower, like a straight up and down. But if you make this number bigger, then they'll kind of spread out over an area. And we'll experiment with different values, of course, and see. So this is going to be the x offset, the y offset, and the z offset. And again, we will look at those. Cool. Next is, first of all, it looks like I forgot a comma. Okay, there are 3 parts left. The next one is another float, and it's the speed of the particles. Now, this doesn't apply to everything. I was originally testing this with the villager happy enum particle, and it wasn't making a difference, and I realized there are certain particles that move. Certain particles just show up and then go away, but the portal particles kind of float around, so you can adjust the speed and make them go fast. So if you make the speed too high, then you'll notice that you actually won't see them because they disappear too quickly. But let's just make it 10 for now, and we'll play with it. But this is the speed. Okay, and then we have next the number of particles. Now you don't want to make this too big, but as your offset increases, you need to make this number larger, or else you're going to not notice the particles. Because if you have 10 particles spread out in a 10 by 10 by 10 area, then you might not notice them, or you may only notice one. So a number up to, I think, 10 or 100,000 will not cause any issues, but I did try it with integer.max value, and it froze the game, and I had to force quit it. So we'll start with, since these are up in a tower, we're going to start with 1,000 there, and that is the number of particles. And then the last parameter is an int array, and we're just going to set that to be null. I don't know what it does, but it didn't seem to really be affecting anything. So now we have this packet set up, and we kind of, by experimentation and by using other resources, can figure out what all of these different pieces of data are. But you can clearly see how powerful this is. We can choose from a ton of particles. We can choose the exact position and the sort of radius or the offset where they can be, the speed of the particles, and the number of particles. So there's a lot of power that you have here. Now we need to send the packet to the player. And we're going to do this by, first, we need to cast player to craft player. And this is a safe cast because player extends or implements craft player. So here, craft player implements player. So we can safely make this cast since player is a craft player. And then we can say we need to get access to, did I do something wrong? Let me see if I did something wrong. We need to import craft player, of course. And then we're going to cast to craft player, then do get handle dot player connection dot send packet, and we're going to send them our packet. So the first part, again, casting to craft player, which is essentially the craft bucket part of player. So it implements player, and a craft player will contain everything that the player will have, but it also has some other things in it, like this get handle, which returns entity human, which we can then get their connection, which is a player connection. And you can see in here all of these entities have a lot of sort of methods in them. And then we can finally send the packet. And sending the packet will deploy it. It'll look like a normal packet coming from the server, but it'll really be our own custom packet that we made. So this is ready to test. Just one last thing. If you take a look up here, anytime you see net.minecraft.server dot and then this v18r3, anytime you see anything like that, the main issue with packets is that every version of Bukkit or Spigot that gets released, this will change. So, when new versions of the Minecraft server are released, then this will change. So in 1.7, it was v1_7_10 or v1_7, and, different are, I believe, revision numbers. So the best thing to do is Command-Shift-O, which will organize your imports. So if I just type out PacketPlayOutWorldParticles and I organize my imports, it'll automatically import the correct file. It'll find the correct location. And if it's not finding it, then you probably don't have Craft Bukkit on your build path. So just make sure that you keep that in mind. If you try to use this plugin on an older version of Minecraft server or a newer version, if and when there is one, then it will give you an error because you're referring to these classes in this package where they're not actually in that package. So just keep that in mind. I'm going to go ahead and export this, and then I'm going to start up the server. And I also need to go over to Minecraft so I can join the server and demonstrate. And we're just going to try modifying the different values and see what happens. Alright, cool. So I am, server is started, and I can connect to it. Cool. Alright, so here I am on the server, and this is a pretty good area for testing. So what's going to happen is I'm going to click on a block, and it's going to do the effect, and we're going to play with it a little bit. But there, I click on the block, and you'll notice all of these sort of particles that are flying around, and you'll see that there are a lot, and then they disappear pretty quickly. Now, we're just going to try playing with these different values. So let's say that we bring the offset, X, Y, and Z offset up. And over here we'll hit it. You'll see that it modifies the area, or not the area, but it modifies how wide of a radius they can be. So if I set this to, let's say, 100 and 100 and 100, and let's reload, and 0, and then I click, you'll see that we don't really see anything. I just saw one particle, but now I'm not really seeing much of anything. And that's because we made the radius very large, and there aren't that many particles. So they kind of get spread out, and we don't really see them. So that is an issue there. So let's try and make these smaller numbers. And we can increase the number of particles. So this is 1,000,000 particles. Export, reload, cool. So you'll see right now it kind of just froze for a second. Now you'll notice, look at all of these particles. It's spawning 1,000,000 particles at once, which is the cause for the lag. But you'll notice that there are a ton of them. So we want to try to keep this number smaller. I think around 10,000 shouldn't cause too much lag. But we do want to keep that number small. So let's try it again. And you'll see there was no lag that time, but there still are a lot of them. And of course we can modify the speed. So if we change that from a 10 down to a 1, they should go somewhat slower. You'll see they do stick around a little bit longer, although they are pretty short-lived. So that is something to keep in mind. Now the one strange thing is, when I was setting these to 0, I was getting them all in a straight vertical line, which it wasn't doing before. So you can see that there it kind of makes a very small area that then converges on that point. So that's a cool little effect there. But let's try changing the portal. So I was using Villager Happy, which is just like a pink diamond. And so let's see what that looks like. Okay. So I click. Did I reload? Yeah, I think I did. I don't see anything at all. How strange. Let's just try playing around with the numbers a little bit. And I want to see, there we go. So you can see that we kind of get this like explosion of green particles, and then they kind of all just twinkle out. And if we increase the radius, let's just say we do 5, 5, and 5. hit export. Then you'll notice that the radius is now a lot bigger, and the particles are a bit more spread out. So now there's this big radius of particles, and then they'll all kind of twinkle out. And of course you can set the number of particles, so you could have a ton of particles at once, like this is a pretty big number, or you could just have a very small number if we make that smaller. So this was a first look at packets. This was the first packet which can play an effect to a particular user. And you can see that we have a ton of customizing that we can do. We can specify all of these different pieces of data so that we can get the exact effect that we want. So I'd recommend playing around with this packet now that you know more or less what all of the different properties or all the different parameters of the constructor do. And you can kind of customize the effect that you want to have. Just keep in mind that whole thing about this plugin will work on this Minecraft server. It will not work on a server that's running Minecraft 1.7. All you'd have to do is you'd put in a 1.7 bucket instead of a 1.8 bucket, and you'd import, and it would just import it from v1_7_ whatever, and then you would be good to go. And this packet should be the same, but there is an older version of the PacketPlayOutWorldParticles that takes a string instead of an enum particle. So if you're getting errors like that, just go look it up. I'll stick a link in the description to the older version, which is similar to this, but not quite the same. So, as always, subscribe if you want to see more. Comment below with what else you want to see in the Packet series. And if you like this video, click the like button. I'll see you guys soon with some more coding. Bye for now.